Hello friends, welcome to Geospatial Tube. Today I'm gonna show you how to download free digital elevation model, slope, aspect, hillshade, surface roughness and other terrain parameters from open topography site within a single click. Before we go to the practical aspect, as usual, I would like to remind you to subscribe my YouTube channel. Let's get started. Download the terrain parameters from open topography site. The first step that we are going to do is open your internet browser. It can be Google Chrome, Firefox, Crypto or any other internet browser and type google.com to gain a search bar. After having this, we are expected to write it as open topography. This is a site to download the different terrain parameters for free. So after having this is a pop-up window and with different options. From this, click on open topography home. Provide a service for the hosting, management, distribution and processing of high resolution topography data for academic institutions, for government and for commercial stakeholders. So to gain the data, open the topography home, and it needs also the internet connection. So this is the interface, open topography, high resolution topography data and tools. There are different options here. There is photo data, find data maps, click here. Here there is the interface of open topography, find the topography data. Here is, as far as the data source is concerned, we have open topography data source, United States Geological Survey, 3DEP, NOAA, community data space, global and regional digital elevation model. So you can select here. There are different parameters, different spatial resolution. For instance, USGS 1 meter spatial resolution for the United States of America. There is 30 meters, but I'm very much interested to select SRTM GL1 and GL3. Click here. For the sake of view, here there is United States view, a global view, and here instead of showing the topographic structure of the world, this is terrain. We have hybrid and there is also a satellite. If we are selecting a satellite, there is a satellite image, but for the sake of clearly show the demarcation of the boundary, I prefer to use a terrain. Then the next is there is zoom in, zoom out. The next step is zoom in to your area of interest and select a region. Click here and you can use this rectangle, so you can drag and create this polygon to down, and the result is indicated here. The total 8 datasets are found within all data sources. As far as the data source is concerned, as I have shown earlier, all those data sources, but in the case of my area of interest, only 2 data sources contribute or have a data. So I have 8 data, one from the community contributor data source and the other is from global and regional digital elevation model. The next is here there are different data with different data providers: the global ecosystem dynamics investigation, the Copernicus global digital elevation model, the NASA DEM global digital elevation model, the global bathymetry and topography at 50 arcsec, the global multi-resolution topography, a shuttle radar topographic mission data are available, but I am interested to use a shuttle radar topographic machine. So here 3 datas. The first one is SRTM with a spatial resolution of 90 meters. To see that, click here and this indicated a shuttle radar topographic machine of SRTM with a spatial resolution of 90 meters. Let's get back. SRTM GL1 have a spatial resolution of 30 meters, so I'm very much interested to download the digital elevation model and other extra parameters. Like to download this, go down and we have outputs. The first one is the coordinate system. As far as the coordinate system is concerned, we have two kinds of projection system. The first one is geographic coordinate systems that indicated with the help of decimal degree or degree millisecond. The second one is projected coordinate system that is expressed in terms of meter. Here the selected area is expressed in terms of the geographic coordinate system with the coordinate of WGS 1984. The data selection coordinates are manually entered, or selection coordinates tick here. Here there is x minimum, y minimum, x maximum, y minimum. This indicates that x minimum means this is x minimum, this point, and here this point is x maximum, whereas this point is y minimum, here is y maximum. So there is xy plane, so x minimum, x and x maximum, y minimum and y maximum is clearly indicated here. If you are moving your cursor to this, it indicates latitude, the minimum latitude. If you are moving here, the maximum latitude, this indicates longitudinal values. Click here to validate the coordinate and estimate area. Click here and automatically generate the total area of my area of interest. So my area of interest is estimated to be 6,392 kilometers square. The second is data output format. We can download in terms of ArcSed grid or in terms of GeoTIFF or image, but GeoTIFF is my preference and I am comfortable with GeoTIFF, so select GeoTIFF. The third parameter is visualization type. Let me download a hillshade, color relief. You can download the color relief, color hillshade, slope, aspect and roughness. The output format, you can select image or TIFF. I'm very much interested to use TIFF. The other is I would like to use all the selected formats in terms of KMZ or KML file format to visualize on Google Earth. So tick here, and I would like to increase the vertical exaggeration to 15. The altitude of light source is at 45 degree. The azimuth is 350. So the final one is job description. This site asks your job and your job description as well as your email address. So let me say researcher, or you can write your job title. You can also describe your job for research purpose, and finally you are expected to give your email address. So finally, after completing all the requests, click submit. This is a pop-up window. This indicates that this is ongoing process to download the digital elevation model, or it is successfully completed because there is a sign of right mark. The second is the ongoing process to generate hillshade, slope, aspect, surface roughness and other terrain parameters that we are selected earlier. So after completing this process, we will gain all the data that we are requested to gain from Open Topography datasite. Here is the job ID. This is a dataset that I am requesting. So the process is completed. Here the downloaded data are listed here. The downloaded compressed raster data with a size of 8.8 megabyte. the downloaded visualized product with 82.9 megabytes. So now we can simply download this, and we can also see the selected parameters here. So let's download it, download this, and also download the visualization product. Click here. After downloading all the required data, let me show you on ArcGIS. First of all, we are expected to open our ArcMap. Go add the downloaded data. Before that, we need to extract the data. To do that, this is the raster data that I have downloaded. So extract, right click, extract file, make it okay. Let me extract this, right click, extract file, yes. I have extracted all the data, so add data, and let me go to D drive. This is the file. This is aspect, color relief, hillshade, color, roughness, slope. Let me add all the data. Okay, all these are the downloaded data from Open Topography site. Let me show one by one. This is the aspect map of my area of interest. If you are interested to clip out based on your administrative boundary, you can add. Let me add and let me show you. This is the administrative boundary. You can clip out by this. Anyways, this is the administrative boundary of my area of interest. So this is a hillshade. Let me show you color relief. This is a color relief. This indicates the color relief of the downloaded area. Here there is a hillshade. The hillshade indicates this is a lower area, this is a highland one. We have also color hillshade. This is surface roughness. Simply this is a lowland area. Here is a slope. This is a slope map. You can also make classification. For instance, we can classify into 5 or something like that by using FAO slope class. So this is a slope map. In addition to this, I would like to add the data, the digital elevation data. This is, make it yes. So simply this is a digital elevation model that we are downloaded from Open Topography data. This is all about the free access data from Open Topography site. If you have any question, please welcome. Thank you very much for your attention. Have a nice day.